Hi everyone, we're Team 2, and we'll be talking about a completely renewable process for producing methanol through the hydrogenation of carbon dioxide. My name is Josh Allers, I'm the General Manager. On our team we have Ryan Alcala, who is the production expert, who has experience with catalytic conversion of hydrocarbons to alcohols. We have Eric Amdahl, who is the environmental and safety expert. Jacob Flack and Spencer McDonald will be handling the simulation aspects, including Aspen. And with me here, I have Sterling Saltz, who is our economist, and he'll be giving a brief overview of our projects.
We chose CO2 to methanol. Methanol can be used as a fuel, solvent, or even as antifreeze. We will be selling this methanol to a formaldehyde producer located in Texas. Also, formaldehyde can be used as industrial resin, particle board, or even as coating. We had some motivation for choosing CO2 to methanol. Chose CO2 to methanol because 81% of greenhouse gases are CO2. They trap heat in the atmosphere, can increase or lead to an increase in global temperature. Our conversion method is direct hydrogenation of CO2 to methanol. We would like to incorporate a new novel catalyst in this process. This process is actually very common across the entire industry. The location of our plant will be at NRG Texas Power LLC. It's located in La Porte, Texas. This is right outside of Houston. It gives us a nice access right on the coast. As well, we will be receiving flue gases from the plant, from NRG Texas Power. We'll be using this as our source of CO2 for methanol production. Also, we will be selling our methanol to a company called Georgia Pacific. This is located in Texas, about a 2-hour drive from our power plant in La Porte, Texas. Now, we have some goals here. We would like to achieve a high conversion of CO2 to methanol, higher than recently recorded in industrial and simulated processes. Try to achieve at least 25%. As well, we would like to run a carbon negative plant. But our main goal is to run a renewable CO2 to methanol plant, comparable profit margin to a non-renewable CO2 to methanol plant. But Josh will be going over most of this in the next slide.
Thank you, Sterling. So I'll go over the block flow diagram a little bit. So the flue gas from the power plant will be fed into a CO2 capture unit, which will produce our CO2, or will isolate the CO2 from the flue gas. The hydrogen will be produced through the electrolysis of water. Once we have the CO2 and hydrogen, they'll be fed into a reactor with a catalyst. This reduces the activation energy, allowing us to hydrogenate the CO2. Any unreacted CO2 or hydrogen will be fed back into the reactor to fully react. The products will be sent to a separation process where we will isolate the methanol from byproducts and wastewater. Some byproducts we expect to see include methane, methylformate, and dimethyl ether. These are also valuable products that we could potentially sell to increase our profit margin. And the wastewater can also be used, can also be fed back into the electrolysis unit in order to save some costs with the water. Some things to think about when designing this project include capital costs and operation costs, but also the safety aspects. So using hydrogen can be very dangerous due to the flammability, and producing methanol, you have to keep in mind how flammable it is as well. Also, being so close to the coastline, we want to avoid spills, and if there are spills, how to prevent them from actually reaching the coast. So that was a brief overview of our project. We hope you will consider us as a viable team for this project.